Okay, we've all been there, right? You check the weather, you plan your entire day around glorious sunshine, and then boom, rain. It can feel like a total guess, but what's really happening is this incredible dance between global observation and just raw computing power. So today, let's actually pull back the curtain and see how a forecast is really put together.
This is the classic question, isn't it? And when a forecast flips on a dime like that, it's more than just frustrating, it's actually a clue that points to a deeply complex process. So we're going to unpack that whole thing and find the answer.
So, where does a forecast even begin? Well, it's not with a prediction. It actually starts with observation. The very first job is to get a perfect, real-time snapshot of what the atmosphere is doing right now all across the entire planet. And that might sound simple, but think about it. It's a monumental task. The atmosphere isn't static. It's this three-dimensional, constantly moving target. So the first step is just this massive, relentless data collection effort, 24/7, just to try and pin down what it's doing at any given moment.
And we're not talking about just a few weather stations here. This is a vast global network. You've got thousands of stations on land, ships, and buoys reporting from the middle of the ocean, and weather balloons launched twice a day that climb up to 30 kilometers high, sending back vital data the whole way. You add in reports from commercial aircraft, and of course, our eyes in the sky, the satellites, and all these pieces have to come together to create that one initial snapshot.
I just love this way of thinking about it. All those millions of data points streaming in every few hours from all over the world, they aren't just a bunch of numbers. Each one is like a single pixel, and together they combine to form this high-resolution image of the living, breathing sky at one single moment in time. So while satellites are giving us that big picture from way up high, radar gives us a much more intimate local view. It literally sees inside storms by bouncing radio waves off of rain and snow. This is how you get those colorful maps on the news that show exactly where it's raining right this second and where that rain is headed in the next hour or so. It's the absolute key to what we call nowcasting. Okay, so we've got our snapshot of the present. Now what? Well, all of that data gets fed into some of the most powerful supercomputers on Earth, and their job is to try and simulate what the atmosphere is going to do next. This whole process has a name. It's called numerical weather prediction, or NWP for short. And it's not magic, it's physics. The computers are programmed with the fundamental laws of thermodynamics, fluid dynamics, and motion to calculate how the atmosphere is going to evolve from that initial snapshot. So how does it actually work? Well, the computer takes those millions of observations, and then it lays this massive 3D grid over the entire planet and up through the atmosphere. Then it gets to work. For each little cube in that grid, it calculates how the temperature, the wind, and the moisture will change over the next few minutes based on the laws of physics and what's happening in all the cubes around it. And then it just does that again and again and again, building a forecast step by step, hour by hour.
But here's the twist. You'd think with all this incredible technology, the process would be totally automatic, but it's not. And this is the crucial part. The human expert, the meteorologist, is still absolutely essential to the whole thing. Let's see why.
You see, a supercomputer just spits out one possible future based on the raw data it got. A human meteorologist, though, they provide interpretation and context. They don't just look at one computer model. They compare several of the big ones, like the American model, the European one, the UK Met Office model, which might all have slightly different ideas. And most importantly, they add that critical local knowledge. And this is where their real value shines. A forecaster who has worked in a region for years knows exactly how a sea breeze behaves on a summer afternoon, or how air flows over a specific mountain range. These are the kinds of local nuances that a giant global model, no matter how powerful it is, might just miss. They fine-tune the computer's raw output with their own hard-won experience.
Okay, so we have all the pieces of the puzzle now. We've got the global data, the supercomputer models, and that essential human expert. So we can finally answer our original question. And this is the key insight. When a forecast changes, it's not because the first one was wrong. It's because the forecast is being actively improved. Every few hours, a whole new batch of real-time data comes in. A new snapshot of the atmosphere is taken, and the models are run all over again with that fresher, better information. A changing forecast means the system is working exactly as it should. Now, the deep scientific reason for all this is a really fascinating concept called chaos theory. And what it tells us is that in a system as complex as the atmosphere, tiny, almost imperceptible differences in the starting conditions can lead to wildly different outcomes down the line.
The best way to get your head around this is to think of ripples in a pond. You drop a stone in, and you can predict the first few ripples with amazing accuracy, right? But as they spread out and interact with each other and bounce off the edges, the pattern gets really complex, really messy, and pretty much impossible to predict. The atmosphere behaves in exactly the same way. A tiny error in measuring the temperature over the Pacific can eventually grow into a huge error in a forecast for Paris 5 days later.
So how do forecasters possibly manage all this chaos? Well, one of their most powerful tools is something called an ensemble forecast. What they do is run the same computer model dozens of times, but each time they tweak the starting data just a tiny bit. If all those different runs cluster around the same outcome, the forecaster's confidence is really high. But if they scatter in all different directions, well, that tells the forecaster there's a whole lot of uncertainty about what might happen.
So, with all of this in mind, we can now look at that weather report on our phone from a completely new perspective. It changes everything.
That little icon for sun or rain isn't just a simple prediction. It is the final product of an immense, ongoing collaboration between global observation technology, mind-bendingly powerful computers, and the absolutely irreplaceable judgment of a human expert. It's this careful, constant dance between what we can measure and what the sky ultimately decides to do.
And this is just the perfect way to think about it. The atmosphere is alive. It is constantly changing. A weather forecast is simply our best attempt at an ongoing conversation with it. So the next time you see a forecast shift, you'll know it's not a mistake. It's just the science, doing its absolute best to keep up.